And basically what we're going to be doing here, yes sir. So basically, we're just going to go over some of these rules as we're working our way down the page. So what I'm going to try to do, we'll see how good I am at keeping a balance with this, is I'm going to try to keep the help sheet on here at all times, just so we can kind of reference it a little bit. So, thank you. On these top ones, I notice on all of them, I'm multiplying the terms together. So whenever I'm multiplying, and I'm dealing with anything with exponents, okay, we're going to add the exponents that have the like base, but one thing we didn't mention here is, okay, if there's a coefficient, if there's a number in front, I'm still just going to multiply those. And I'll admit that's the one thing I've noticed so far as I've kind of strolled around and seen how some of you are doing this. So like for instance here, okay, I see that -7. That's just going to stay -7, okay. But then I'm going to add my exponents with the x's. 2 plus 4, it's 6. It's not anything that's real long to do or real complex, especially when I've got something to refer back to. But here's the one that doesn't look hard, but it can be tricky. If I add my exponents on number 2, what exponent do I end up with? Yeah, see, that's why this one's tricky. What exponent's on a variable if I don't see one? 1. So it's really 1 plus 2 plus 4. Because a lot of times people will write 6 because they only see the 4 and the 2. So you've really got to be careful if you have one that doesn't have an exponent to remember that that's there. And sometimes it's even not a bad idea to go ahead and write those ones on there, so when we do get to one of these, we can work that out. So all right, can I just add all my exponents up here and call it, I don't know, something to the 8th? No, because they have different bases. Okay, so what if we start with r, since that's the first one I see? What's its exponent going to be? 2. So I got 1r here and 1r here. S, I only have one of those. And you could just put s, or if you put s to the first, that's the same thing. It doesn't hurt. And then right, my n is going to be 5. I couldn't agree more. So that's how that's going to work. Okay. Whenever we're doing the multiplying, we're just doing that. Rearrange this a little bit. So when we get to the next one, we get one twist thrown in. Now it may look off the start like it's just plain multiplication, but now I'm starting to see an exponent on the outside, a sum of my parentheses. When that happens, that's called power to power. And you multiply the exponents, and you'll even notice on the example, it's like it distributes through. It makes sure it goes to everything. So we're going to do that here. That 3 that's out here, since it's outside the parentheses, goes all the way through to all of these. And remember, I have an exponent of 1 on my a, and I've also got that exponent of 1 on my -3, since I don't see it. Now we're going to come back to the -3 in a minute here. But my other ones, I'm just multiplying. 1 times 3 is 3. 4 times 3 is 12. But then when I get to -3 to the 3rd, there's a couple of things I could do. But I do want to make note of one thing. And it's that I want to make sure that whenever something's been in parentheses, that I put it in parentheses when I go to type it in. Now this time it wouldn't have mattered, because even if I'd have typed in -3 to the 3rd, okay, you're like, I'd get -27. So what's the big deal? Because when I do get to a problem sometime that has an even exponent, so like let's say it would have been -3 squared this time. Oops, I know what I did. And I get 9, but then I forget to put the parentheses. I did it again. And I get a different answer. So just the general rule is make sure that you use parentheses if that ever happens, but I can still get to my answer. But I will throw some twists in sometimes, see if you're paying attention. Like here, my 3 and my 2, they're not outside the parentheses. The only one that's power to power is right here. And it just goes to that one term that's in the parentheses. So I'm going to leave everything in the first one alone because it doesn't have an exponent up here. What's this b term going to turn into? B to the what? 6. Okay? Because it's 3 times 2. And once I've cleared that up, is there anything else I can put together? Yeah. Now the b's can still go there. Now do I multiply those? Is that b to the 12th? No. Because now I'm just multiplying. There's no power to power anymore. So I'm just going to add them up. So I always have to be watching when I'm doing these to see if any exponents I have, if they're outside the parentheses, I've got to distribute them through. So I'd have 4 squared and then multiply those. But the b to the 3rd doesn't have an exponent out there. And I suppose even if you left this as the answer to be okay, but we always want to simplify. We always want things in simplest form. So what's 4 squared equal? 16. Okay, because it's 4 times 4. These act differently than our exponents. It's not 4 times 2. And I get to my answer. So you kind of keep noticing, it's like if I just know these like 2 or 3 rules, this isn't going to go too terribly awful here. Oh good, more stuff with power to power and multiplying exponents. So this one for 7, is that end of the 11th or end of the 28th? 28, because it's power to power. I'm going to multiply them. Get my answer. Here I have no power to power. I'm just multiplying things together. So I take a peek and I go, okay, I got to remember I won there. So I'm multiplying, so I add my a's. I don't have any other d's, so I'm just going to write that down. And then now let's see here, 3 and negative 2. So 3 and negative 2. Well, I've been adding before, so if I add them up, is that supposed to be 1? No, what should it be? What do I do to the coefficients? Negative 6, because I'm still multiplying them. And work that out. Okay, so sometimes they can be really short. Other times, if you get an exponent out there, there's lots of stuff going on inside. Holy cow. And I just multiply it out. So 2 to the 3rd, power to power, I'm multiplying all these exponents. And again, it's worth your time to take your time and make sure you do it right. Because if you don't, well, you're just going to miss it on a quiz, and if it was anything else, you'd have to just do it again anyway. 2 times 4 is 8. 1 times 4 is 4. And now, basically, 2 to the 3rd power, again, whether you go to the calculator or doing it yourself, remember, that means 2 times 2 times 2, which is 8. And then go looking for things that are alike you can put together. Now that I'm just multiplying, I'm going to add the exponents. 9 and 8, 17. I only got one y term, so let's write that down. And then I've got my z's. We're going to test your attention to detail. Then we get our first peek at exponents with dividing. Subtract and place the answer where the larger exponent is. So we're always going to do bigger minus smaller. So when I look here, I go, okay, I'm going to put my fraction bar back in. 5 minus 2 is 3, but the bigger exponent's up here. So I put the answer up here. With my ends, 4 minus 1 is 3. Bigger ones up top. What if there's nothing left down here? Well, I could put a 1. Or if there's nothing left in the bottom, I could just write it p to the third, n to the third. Either one's fine. But when you're dividing, you've got to make sure the answer ends up where the biggest exponent is. With my numbers, what if I get something that's like a fraction? Because remember, I've got to be careful. This isn't 14 divided by 2, so I can't write 7. It's negative 2 divided by 14. Now, we don't want a decimal. Okay, negative 1/7. Okay, so the calculator can even help me with that if it needs to. And then since I'm dividing with the y's, 7 minus 5 is 2. The bigger exponent's on top. We're good. So that's all I'm doing with these. I've got to watch for which one's which. X to the 1 minus 1. Oh, 1 minus 1 is 0. Okay, so they just canceled out. Y to the 6 minus 4 is 2. And I get my answer. If the 6 would have been on the bottom, then I'd have had my y to the 2 on the bottom of my fraction. And that's how that would have worked out for me. But again, it's just those 4 rules that we're working with. Nothing else is going to really change. But when we get to the back, we are going to start working with some where we get to do a little of everything. But whenever I see the parentheses, my first job is to always work that out first. So I've got 3 to the 4th. 6 times 4 is 24. 3 times 4 is 12. You may be thinking, do I even do it to the bottom? It's in the parentheses. So that 4 goes all the way through there too. 5 times 4 is 20. 1 times 4 is 4. So let's see here. 3 to the 4th is 3 times 3 times 3 times 3, but I don't want to have to type that in that many times. So I'll just use my little caret button here. So 81, 2 to the 4th is 16. Now if I'm not sure if that'll reduce or not, again, just about every calculator you have anymore, whether it's one of these or one of the ones you work with there, if you do math, enter, nope, doesn't get any smaller because I got the same thing back. Okay, let me shrink that down. 24 minus 20 is 4. Bigger one's up top. 12 minus 4 is 8. Bigger one's up top. And I'm set. And then the one rule we haven't played with yet. Negative exponents. If they're there, you need to flip them. Like, what do you mean? Well, that 2 to the 2nd is got a positive exponent. It just stays the way it is. But that 2, and I think that's a negative 3 that's down there. What that means is, if it's a negative exponent and I flip it, in other words, it goes from the bottom to the top, it becomes positive. So I always want to flip those negative exponents first. And then if I got nothing left down here, I can always just put a 1. So 2 to the 2 plus 3, since I'm multiplying, it'd be 2 to the 5th. And I get my answer. If you wanted to punch that in the calculator and get the number, you could. Here, p to the 3rd, that's still where it belongs. I think that's p to the negative 8th. Negative, it's on top. If I flip it to the bottom, it becomes positive. But I have to flip it to the opposite place. So if it's in the numerator, it goes to the denominator. Put a 1 where I don't have anything left. And then I'm just going to add my exponents. But negative exponents, that's the thing. I can't just turn them positive. I actually got to flip them. I got to do something to them to make that work. Now we start to get to put everything together. I see parentheses. I'm going to do that first. So I'll multiply those. Here, ooh, it's a negative. This isn't going to be fun. I'll still distribute it just like I would with any exponent. And then when I get here, before I do anything else, I'm going to do my necessary flipping. Now notice, I didn't move either of these. They both have positive exponents. They have good attitudes towards things. I can leave them be. But these two guys, they're on the bottom. If I move them each up to the top, they'll become positive. And again, I got nothing left down below, so let's put a 1 there. But now, it went from being a division problem to where I'm just multiplying them, where I'm going to add the exponents. So a to the 6th, 6 plus 2 is b to the 8th, and I can put it over 1, or since all my stuff's in the numerator, I can just leave it. Because dividing something by 1 isn't going to change the value at all. Oh, and the trick problem. Anything to the 0 power, all that stuff. That 0 power takes everything in here and just turns into 1. We talked about that on Friday. All right, now we'll start blending here. 12 over 36. Anybody that's messing with that, does that reduce at all? Is anything divided into 12 and 36? Yes. Again, no decimals. 1 over 3. And then I'm dividing. 5 minus 1, because if I don't see an exponent, it's there, is 4. Bigger exponents up top. Good, good, good. Get the calculator out of the way here. Last couple. Get that out of the way. So I'm looking, and I'm like, okay, g to the 4th, you're positive. You get to stay. F to the negative 5th, bad. You have to move. H to the negative 2, change that attitude. Flip you back up to the top. But then I look a minute, I'm like, hey, F, G, H. None of the variables are the same. Now what? Nothing. I just had to get my exponents to be positive. That's all there was. So it's those little things. Like here, no exponents outside. I just got to clean up here. We're still multiplying the coefficients. Put my little 1s in there. Still taking my variable terms and adding the exponents. 1 and 5, add the exponents. 2 and 1, add the exponents. The quiz tomorrow will be just like this. So that's one thing to kind of keep an eye on, to keep track of, and make sure I'm not missing anything. Oh yeah. In homework check number 4, there's 4 assignments in it. Okay, those are listed on the backboard. Most of those are still over in the folders there too, if you need any of those. And that'll kind of be our gist of things tomorrow. And then Thursday, we're going to get to start with the one other big part of our section, which is called exponential growth and decay. We get to play with graphing this stuff on the graphing calculators a little bit. It's kind of interesting.